Hello everybody, in this video we'll be looking at expressing improper fractions as partial fractions. So improper fractions are those where the degree of a numerator is greater than or equal to the degree of a denominator. And you can see this in example 1, where the highest degree in the numerator is x to the 4 and the highest degree in the denominator is x to the 2. So therefore this is an improper fraction, which means we can split it into a polynomial and a ordinary fraction. And to get it into this form, we need to use long division. So we have our numerator, x to the 4, plus 0x cubed minus 3x squared plus 0x plus a 5. And we're dividing this by x squared, 0x, and a positive 2 for a constant. So to carry out this division, we'll start by dividing this x to the 4 by x squared, and we get positive x squared. So now we'll multiply this by each of these terms, and you can see we get x to the 4 plus 0x cubed and then plus 2x. When we work out the difference between these powers, well, x to the 4 take away x to the 4 is 0. 0x cubed take away itself is also 0. And then we get negative 3x squared take away 2x squared, which will give us minus 5x squared. So now we go through this process again. We divide the negative 5x squared by the x squared, and we get negative 5. And then we multiply this negative 5 by each of these terms. So negative 5 times the x squared gives us negative 5x squared. Negative 5 times 0x gives us 0x. And negative 5 times 2 gives us negative 10. And to work out the difference between these terms, well, we can drop each of these down first. So 0x and then positive 5. And the difference between this negative 5x squared and this negative 5x squared is 0. The difference between these is also 0. And the difference between these is positive 15. So this x squared minus 5 is our quotient. So we get x squared minus 5 plus, then we have our remainder, which is 15. So plus 15 divided by the original divisor here, so divided by x squared plus 2. So in this case, a is equal to 1, b is equal to negative 5, and c is equal to 15. Okay? In this example, we didn't need to use partial fractions, but I wanted to show you how to break it down into a polynomial and an ordinary fraction. In example 2, we'll follow the same idea, but then we'll look at partial fractions when we have our remainder. Okay, so do you want to try and break this down into a polynomial and an ordinary fraction using long division? You can pause the video, and when we come back, we'll go through the worked solution. Okay, so welcome back if you're ready to go. So we have our numerator, which we're going to divide by the product of x minus 2 and x minus 1. So to do this, we need to expand these brackets out, and we get x squared minus 3x plus 2. And we can tell this is an improper fraction because the highest power in this numerator is 2, and the highest power in the denominator is also 2. And it is because these two powers are equal that makes it an improper fraction. So we'll start dividing x squared by this x squared, and we get 1. And then we'll start multiplying out through this 1. So we get 1x squared minus 3x plus 2. And the difference between these expressions, well, the difference between the x squared is 0. The difference between the x terms is 4 take away negative 3, so 7x. And then the negative 7 take away the 2, which gives us negative 9. So now we can write this as a mixed fraction, where we have our quotient of 1 plus the remainder of 7x minus 9 over the original divisor, x minus 2 and x minus 1. And now we can use partial fractions to simplify this fraction. So we can say that 7x minus 9 over x squared minus 3x plus 2 is identical to a constant a over x minus 2 plus a constant b over x minus 1. And it is these constants a and b which we need to find. So we can cancel out the denominators by multiplying both sides by x minus 2 and x minus 1. And we can see they will cancel on the left hand side. These x minus 2's will cancel, and this x minus 1 will cancel with this one. So now we have 7x minus 9 is equal to a, lots of x minus 1, plus b, lots of x minus 2. And we can work out the value of a by letting x equal positive 2, because then this bracket will become 0. I'll just block this off here. So if we say let x equal 2, then we have 14 take away 9, so 5 is equal to 2 take away 1, which is 1, so 5 will equal a. And now we can work out the b term by letting x equal positive 1. So we get 7 take away 9, which is negative 2, is equal to, this will go, and 1 take away 2 is negative 1, so minus b. So therefore b will equal positive 2. So with partial fractions, we can write this improper fraction as 1 plus 5 over x minus 2 plus 3 over x minus 1. Okay? Well, I hope you found that useful, and you've got a better idea on how to write improper fractions using partial fractions. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.